A monsoon is traditionally a seasonal reversing wind accompanied by corresponding changes in precipitation, but is now used to describe seasonal changes in atmospheric circulation and precipitation, associated with annual latitudinal oscillation of the intertropical convergence zone between its limits to the north and south of the equator. Usually, the term monsoon is used to refer to the rainy phase of a seasonally changing pattern. Although technically there is also a dry phase. The term is also sometimes used to describe locally heavy but short-term rains. The major monsoon systems of the world consist of the West African and Asia-Australian monsoons. The inclusion of the North American monsoon and South American monsoon with incomplete wind reversal has been debated. The term was first used in English in British India and neighboring countries to refer to the big seasonal winds blowing from the Bay of Bengal and Arabian Sea in the southwest, bringing heavy rainfall to the area. The etymology of the word monsoon is not wholly certain. The English monsoon came from Portuguese monsão, ultimately from Arabic mawsim, perhaps partly via early modern Dutch monsoon. Strengthening of the Asian monsoon has been linked to the uplift of the Tibetan Plateau after the collision of the Indian subcontinent and Asia around 50 million years ago. Because of studies of records from the Arabian Sea and that of the wind-blown dust in the Loess Plateau of China, many geologists believe the monsoon first became strong around 8 million years ago. More recently, studies of plant fossils in China and new long-duration sediment records from the South China Sea led to a timing of the monsoon beginning 15 to 20 million years ago and linked to early Tibetan uplift. Testing of this hypothesis awaits deep ocean sampling by the Integrated Ocean Drilling Program. The monsoon has varied significantly in strength since this time, largely linked to global climate change, especially the cycle of the Pleistocene ice ages. A study of marine plankton suggested that the Indian monsoon strengthened around 5 million years ago. Then, during ice periods, the sea level fell and the Indonesian seaway closed. When this happened, cold waters in the Pacific were impeded from flowing into the Indian Ocean. It is believed that the resulting increase in sea surface temperatures in the Indian Ocean increased the intensity of monsoons. 5 episodes during the Quaternary at 2.22 ma. 0.45 ma. The weakening of the LC would have an effect on the sea surface temperature field in the Indian Ocean, as the Indonesian throughflow generally warms the Indian Ocean. Thus these 5 intervals could probably be those of considerable lowering of SST in the Indian Ocean and would have influenced Indian monsoon intensity. During the weak LC, there is the possibility of reduced intensity of the Indian winter monsoon and strong summer monsoon, because of change in the Indian Ocean dipole due to reduction in net heat input to the Indian Ocean through the Indonesian throughflow. Thus a better understanding of the possible links between El Niño, Western Pacific warm pool, Indonesian throughflow, wind pattern of Western Australia, and ice volume expansion and contraction can be obtained by studying the behavior of the LC during Quaternary at close stratigraphic intervals. The impact of monsoon on the local weather is different from place to place. In some places there is just a likelihood of having a little more or less rain. In other places, quasi-semi-deserts are turned into vivid green grasslands where all sorts of plants and crops can flourish. The Indian monsoon turns large parts of India from a kind of semi-desert into green lands. See photos only taken 3 months apart in the Western Ghats. In places like this it is crucial for farmers to have the right timing for putting the seeds on the fields, as it is essential to use all the rain that is available for growing crops. Monsoons were once considered as a large-scale sea breeze caused by higher temperature over land than in the ocean. This is no longer considered as the cause, and the monsoon is now considered a planetary scale phenomenon involving the annual migration of the intertropical convergence zone between its northern and southern limits. The limits of the ITCZ vary according to the land-sea heating contrast, and it is thought that the northern extent of the monsoon in South Asia is influenced by the high Tibetan Plateau. These temperature imbalances happen because oceans and land absorb heat in different ways. Over oceans, The air temperature remains relatively stable for two reasons. Water has a relatively high heat capacity, and they can only transmit heat into the earth by conduction and not by convection. Therefore, bodies of water stay at a more even temperature, while land temperature are more variable. During warmer months, sunlight heats the surfaces of both land and oceans. But land temperatures rise more.